is on our performance review, I need to get this set up to work using it's a performance exam review, guys. Problem number 4, if you look on 4 on the sheet, this will be on the news item right there below. It will be right there above where you went today. That's where you went today to get that presentation or whatever. Right there above that, I'll put a copy of this page as well as the answers to this page. Okay, I'll have an answer sheet. Then I'll also I'm going to create a little presentation that gives you links to different videos and stuff that kind of show you how to do it or whatever. Okay, the first thing I want to do here is go over problem number 1, guys. Kind of basically what I'm going to do is each day as I meet with the classes, I'll go over the problem that corresponds with that period. So today we're going over the first question. I told you that you ought to plug it into a calculator. Take the y equals button on your calculator and plug in 6x squared plus 13x minus 5 equals 0. If you take one of those calculators and you plug that into the calculator, guys, here is the solution. As the solution is right there where look, that's the solution right there, where it crosses the x-axis. Now, if you see there's a button on your calculator up there across the top called Calculate. If you punch that Calculate, you can use Calculate to find the zeros. Guys, it is certainly a method by which to find the zeros for these things. But to me, guys, what you ought to do is kind of use graphing, and once you have the problem solved by graphing, use one of the other methods to go back and kind of make sure you know what this answer is. If I look here, I can see that that's somewhere between 2 and 3. See, there's 0, -1, -2, 3. So somewhere between -2 and -3 is one of my answers. And then right here, somewhere between 0 and 1 is my other answer. Now I can use another method to solve this, and one of the other methods might be completing the squared, might be quadratic formula, might be, as there's a bunch of different forms or a bunch of different ways to solve an equation. The second way to solve one of these equations is by graphing, guys, or excuse me, graphing was the first method, is by the factoring. Guys, again, when you factor, does this problem have a leading coefficient of 1 or a leading, answer this out loud please, is the leading coefficient 1 or is the leading coefficient not equal to 1? Yeah, it's not equal to 1. Guys, when you have a problem and your leading coefficient is not equal to 1, like in this problem, the way you go about factoring the problem is you set it up equal to 0 and then you multiply a times c. Well, a times c is -30. That's how you go about factoring. Guys, you have to find the factors of -30 whose sum is b. Well, it turns out b is +13. Now here, guys, here is where some of y'all got lost in this process, guys. Y'all thought, or you got the feeling that these factors were going to find themselves on their own. Guys, they're not. There's a process that you have to go through when you factor of listing out what the prime factorization of a number is. And guys, we had a major disconnect on that. I've been trying since the first day of school to get you guys to understand how you find the factors of -30. So 2 goes into there, and I don't have to do -30. I can just do the factors of 30. And I believe I'd rather just find the factors of 30 and then change the signs of them on the other end. So 15, 3 goes in there 5 times. So now I use this as a way to find the factors of -30 that add together and give you 13. Guys, you have to find them. If you can't find them, what do you know about that number? Or excuse me, that equation? It's prime. It doesn't factor. Guys, it doesn't factor. They don't always factor. Can you still come up with a solution to them if they don't factor? Sure. I can still graph it. It just might have irrational numbers. You with me? Guys, it just might have imaginary answers. You might be working a parabola. Look, you might be working a parabola that's graphed up there. And if it's graphed up there, look, it doesn't have any real solutions. Okay, there are no real solutions right there. This one has solutions. What I want to do is go about finding what they are. So what I'm going to try to do is factor this problem. And if you list your prime factors out, eventually you'll come up with 15 and negative 2. Now, if you can't come up with 15 and negative 2, you can still get the answer correct to this problem. You're just going to have to do it another way. Guys, factoring is a way to solve equations. Will it solve all of them? No, because not every equation factors, just like every number doesn't factor. Now, once you find this 15 and negative 2, this is what's so very cool about math. This is Coach Hill, 30th year of teaching. Guys, over those 30 years, math is happening right now because advent of these calculators and technology. It's happening so fast. And my son, right around the corner, graduated from college 4 days ago. I'm about to show you a method he's never seen before. So during the time that he was in college, whoever they are, people figured out another way of factoring. Here's that other way. Guys, 6x squared, okay, plus 15x minus 2x minus 5. This is factor by grouping. He's seen that. Guys, he's seen that right there. The one he hasn't seen is this method right here, because that's a 6x squared, right? 6x plus 15. Because that's a 6x squared right there, come over here and write 6x. Okay, so factor by grouping, we've all seen. Excuse me, guys. Factor by grouping, we've all seen. That was me standing over here, right there after Christmas break, and ripping a piece of paper in half. And I told you at that time, guys, I will keep reminding you of the day that I did that up until the last day of school. So I ripped that piece of paper in half, and I factor this right here as a greatest common factor, 3x, 2x plus 5, minus 1, 2x plus 5. And remember, a very important part about factor by grouping is that right there will be the same. Okay, this 2x plus 5 will be the same. Then when it is, guys, when it is the same, you can go to this next step, 3x minus 1 times 2x plus 5 equals 0. Excuse me, equals 0 right here. And that's how the problem factors. Now, here enter Coach Hill frustration. Okay, because for some reason or another, guys, the idea of how you solve 3x minus 1 equals 0 has gotten away from y'all. Okay? How you go about solving 2x plus 5 equals 0 is what it has been that's been perplexing to some of you guys. I don't know what to tell you there other than, look now, just get your numbers on one side, variables on the other. If you don't understand how to factor, I get that, guys. Factoring's hard. But what I saw so often was for us to get down here to 3x minus 1 and 2x plus 5, and then set the factors up equal to 0 and not know what to do from here down. Guys, from here down should be the part that you walked in the door knowing how to do already. 2x plus 5, 2x equals negative 5. X equals negative 5 halves. So my two answers should be negative 2 1/2 and 1/3. So let's go back to this picture right here. And let's look and see where this solution is. Well, that point right there is supposed to be negative 2.5. This point right here is supposed to be 1/3 when y is 0. And this points where this line, come on, talk to me. The points where this line crosses the x-axis are called the x-intercepts. Very good. Very good, x-intercepts. So guys, that's what we're doing when we find these. And there's more than one way. Guys, as a matter of fact, there are 4 ways of solving an equation. Another way is this completing the square method. Now guys, I was absolutely thrilled the other day when I was first going over this with my 5th period class. My 5th period class kind of gets ahead of us because they have just a little bit more time. And so that in my 5th period class, we were going over this problem right here, and I asked them what one of the methods was, and somebody said complete the square. Guys, completing the square works all the time. Quadratic formula works all the time. All the time. Every single one of them you can solve by quadratic formula or you can solve by completing the square. The problem with the logic is it's hard. It's hard. What's the problem with graphing? Can you always tell where they cross out when you graph? No, that's the problem with graphing. Guys, the problem with factoring is everything doesn't factor. The problem with the quadratic formula and completing the square is sometimes the quadratic formula problems it takes a long time to work them that way. Guys, let's think back to antiquity. Let's think back to 2,000 years ago. This is very cool. 2,000 years ago, I'm a mathematician. And in my house, I have a big sandbox. It's got sand in it. I have a pitcher that's got water in it. I take some water and I flip it out over that sand, and then I smooth that sand out, and I get a stick, and I work this problem out right. I work it out. I get it worked out, and I go, wow, that's pretty cool. Then I transfer it to papyrus or cuneiform or whatever that stuff from your social studies department is. Yes? Guys, that's what went on. And thousands of years ago, their equivalent of Bill Gates said, hey, guess what? Some of these problems that y'all are doing by completing the square, they're easier to work when you factor them. They take 2 minutes to factor. They take me a month to work it out by completing the square. Because I got to put it out here, and I got to get all those steps figured out. I basically have to give up a month's salary for a 1/4 of a sheet of paper. Well, Coach Hill, I wouldn't have done that. Well, that's how this stuff, that's how it happens, guys, that we know how to, that we're using it all this time later. But parabolas have nothing to do with me. Go right outside the door, right there, take a right, bend over and get some water. There's a parabola right there. There's a parabola right there. The fact that this thing right here is working and it's flashing on this board, the lens of that thing right there is shaped like this right here. Parabola. There's a parabola in the lens of that projector right there. The light comes out of a source and reflects or refracts. Which one is it? It refracts. Refract means it bends. Reflection means light hits it and bounces off. That's a reflection. A refraction is light passes through and gets bent and makes this. But it's passing through a little parabola up there. Guys, this stuff that was figured out thousands of years ago is still true today as it ever was. If you're not sure, you don't believe that, flip that phone you got on right there and play Angry Birds. Talk to me. What does the Angry Bird do? He goes up, 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 up. Does what? And then comes down, 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 down. Guys, the path that he's traveling on is a parabola. It's right there programmed inside the code of that game, that application. That application is a quadratic equation. I guarantee you. As it has to be made that way. So anyway, here, watch. Completing the square, certainly doable, but I promise you, it's hard. Okay, completing the square works. The only thing, guys, with completing the square is you always have to have a leading coefficient of 1. So if the leading coefficient isn't 1, what you have to do is you have to change the equation to a point where it is 1. And that's why I did not teach you how to complete the square to any possible solution or any possible problem, because sometimes completing the square is not the most convenient method by which to work a problem. Does it work? It'll always work. Is it easy? Not necessarily. Okay, so what I have here, guys, is I took an equation and I set it up so I can make a trinomial perfect square. Before we went down to the media center today, I talked to you about completing the square. What did I say we did to the middle number to complete the square? We do two things to it. Divide it by 2 and then square it. You take half of it and then square it. Guys, what is half? Guys, half of 13/6. Guys, 1/2 of 13/6 is 13/12. Guys, half of 13/6 is 13/12. Then I want you to square it. Can anybody tell me right now, looking at this fraction right here, what 13/12 squared is? Anybody? 13/12 squared? 169 1/44. Good. 169 1/44. So if I add 169 1/44 to this side, I have to add 169 1/44 to that side. Again, guys, all I just did was I completed the square with this. I took half of 13/6 and squared it. The reason I wanted to do that is so that I could come up with a problem that is a trinomial perfect square. And when I can get it to be a trinomial perfect square, just like before we went to the media center, guys, just like the same thing, this, you take the square root of each of these, and it gives you a way that it factors. Now my problem over here is 5, 6, and 169 1/44. I need to add those two together, but I need a common denominator to do it. Can anybody tell me the common denominator between 6 and 1/44? Okay, the common denominator is 1/44. 12 would be the greatest common factor, or would be 12 would be even a common factor. When you try to find the least common denominator, guys, you find what it goes into, what does 6 go into that 144 also goes into. So the common denominator is 144. Okay, so I got to change 5, 6 to some number over 144. Guys, if you take your calculator and say 144 divided by 6, you'll see that it's 24. If you take 24 and times it by 5, you'll see that that is 120. So now, what I have is 120, guys, 120 plus 169 over 144. Guys, that's 289 1/44. All right, here we go. Now comes the interesting part. Now comes the part that's going to be pretty, I think you're going to like this part, because you're going to recognize it. Guys, you're going to recognize this part here when it comes time to now take the square root of both sides. So when you take the square root of both sides, this side over here is going to give me x plus 13/12 equals plus or minus 17/14. Guys, the very first day of school was the very first time I asked you guys to tell me what the square root of 289 was. Square root of 289 is 17. Everybody good? If it's 13/12 on this side, if it's a positive 13/12 on the left, what is it on the right? Negative 13/12. So x equals negative 13 over 12 plus or minus 17 over 12. Well, what is plus 17? What is 13? Negative 13 plus 17. Negative 13 plus 17. Anybody?
4.
4. So what is 4/12 reduced to? Keep trying. Come on. 1/3, guys. 4 goes into there 1 time. 4 goes into there 3 times. 1/3, just like before. You with me? All right, over here, guys, over here, when we complete the square, now I have negative 13/12 minus 17. Can anybody tell me what negative 13 minus 17 is? Okay, watch. Negative 30 over 12. Is there anybody in the room that can tell me what negative 30 over 12 reduces to? Negative 5 halves. 6 goes in there, 6 goes in there 5 times, 6 goes in there 2 times. Guys, this stuff works. I have 3 questions out there. Somebody over here wanted to ask a question. Toriana, was it you? Do you have a question here? Okay, when you get a common denominator, the way to get a common denominator is you ask yourself, 6 goes into 144 24 times. Then you take 24 and times it by 5. 24 times 5 is 120. So when you add fractions, you have to have a common denominator. Now, again, guys, let's not forget factoring works in this problem. Here's the Berry method that I referred to earlier that my son, who just graduated, would not have ever seen before. Guys, this is brand new. The greatest common factor between these two numbers right here is 3. Drop it. Just drop the 3. 2x plus 5. The greatest common factor between these two numbers right here is the number 2. Just drop it. Just drop it. 3x minus 1. And so your answers are negative 5 halves and positive 1/3. It's the same answer when you graph. It's the same answer when you graph. It's the same answer when you factor. It's the same answer when you complete the square. Guys, it's going to be the same answer when I use the quadratic formula. What I've got to get you guys convinced of is that any one of the 3 methods work. And what's really cool, guys, what's really cool is when you learn how to do more than one method to kind of check yourself to make sure the other way was correct. Guys, use your calculator. Plug an equation into your calculator, then go back and solve it out algebraically and make sure it's correct. 13 squared minus 4 times 6 times negative 5. Guys, you're going to recognize some numbers here again. 169 plus 120. That's 289. And so x equals negative b plus or minus the square root of 289 over 12. Guys, again, this is 2 answers. One of the answers is negative 13 plus 17, which is 4/12, or 1/3. Negative 13 minus 17 is negative 30 over 12. Negative 30 over 12 reduces to negative 5 halves. So there's the third method. Guys, it doesn't matter which of the methods that you do, they all work, guys. All of the and what's going to happen in number 1 on the performance exam is you are going to have to choose 2 of the 4 ways to show that you know how to do something. Guys, there's 4 ways for solving equations. One way is graphing. Another way is factoring. A third way is completing the square. And a 4th way is the quadratic formula. Guys, again, you are going to be able to choose the method by which you solve this one. This may be one you choose to work. Number 1 may be a choice. It may not be. But we're all going to choose number 4. Okay, look at the 5 topics again. Guys, there's 5 topics there. What I'm going to do this afternoon is I'm going to create a presentation that has this video in it, as well as a video probably from Khan Academy or something like that, and also a couple of links maybe from Purple Math or somewhere like that of examples of you working problems that you can do. All right, at this point, I'm going to stop this video